Hey everybody, welcome to the weather breakdown. Storm Goretti is already a fading memory by now, so it's time to take a step back and look forward to what's ahead. We'll take a look at the large scale synoptic flow and we will compare the American and the European model because both of them have not been in agreement at all. One of them was pointing towards a milder solution, while the other one was still holding on to the Arctic air. So we will see if that disagreement still holds by breaking it down into three key components: the large scale synoptic regime, the temperature in the air masses, and the precipitation field. And yes, my voice still sounds off, but you get that one as a freebie. Let's dive straight in. So when we look at our observation here, we have a low pressure area here with a nice comma shape extending like that. You also have a low pressure area here. And if you look at it, there's a delineation here that you can see. And this is the cold conveyor belt emerging from under the warm conveyor belt here, as depicted in the Norwegian cyclone model. There's also a low pressure area here with a nice comma shape extending like that. And as you can see, this whole comma shape resides completely in the cold air mass. They call this an instant occlusion or a cold air cyclogenesis case. There's also an anticyclonical circulation moving in that direction. So there's a high pressure area here as well. There's a rather big ridge here, so you can expect a high pressure area in that location. There's also a ridge here extending towards the north, meaning there's a high pressure area here somewhere, probably extending a little bit to the north. Downstream of this ridge, you can see this high amplitude trough here with a branch branching off towards the west. You can also see a closed anticyclonical circulation in that direction, meaning that this engine combined with this engine funnels frigid air in that location towards the west. So let's now look at our weather charts and see how this situation evolves, guys. Now, if you look at our weather charts here, we can see more or less the same thing as we did in our observations. There's a low pressure area here with a nice comma shape extending like that. You can see the ridge here as we've identified with a high pressure area here and one, as we said, more situated towards the north. You can see downstream of this ridge here, this high amplitude trough. There's a low pressure area here as well. There's a very nice comma shape extending like that as well. As you can see, there's not really a warm conveyor belt attached to the system, hence cold air cyclogenesis. You can also see a warm conveyor belt here, and you can see another remnant of a warm conveyor belt here. Now, as time progresses, what will happen? You will see that this low here starts to be detached from its warm conveyor belt. Let's move forward in time so you can see that in motion. You can see here, see, this low is completely detached here from its warm conveyor belt, leading to its eventual demise. We also mentioned in our last couple of videos that there was going to be a serial cyclogenesis regime with from the Atlantic all lows being funneled towards the east and the northeast. Let's see if that statement still holds true. So if you go forward in time, we see a low pressure area here. We see another one in its wake. We see yet another one in its wake. We see another one in its wake. And we see another one in its wake. So yes, that statement still holds. The American model still predicts the Atlantic bringing in low after low after low after low. Let's see what the European model is actually saying. Do we see the exact same there? So we see here, again, this low completely detached from its warm conveyor belt here, leading to its potential demise. We go forward in time. Do we see lows? We see low number 1 here, right? We see low number 2 here, albeit it's much more north. We see another one here, again, much more north. We see this one. We see this one here. Yeah, it's more or less the same. There's still the Atlantic bringing in low after low after low after low. So on that, they agree rather well. When we look at our temperature field here, let's draw the boundary between the freezing temperatures and the not freezing temperatures, the positive temperatures. So let's keep that boundary there and let's move forward in time. So as these lows start to bash the European mainland, you can see the cold air starting to move more towards the east. If you go forward in time, does it stay that way in the European model? Well, the European model actually gives us a mixed signal, right? If you go forward in time, you can see this impulses of cold, warm, cold, warm, cold, warm. This is the daily cycle, as we can already see, right? So we can see indeed that the temperatures, according to the European model, it pushes it towards the east. Let's see what the American model is doing. Let's keep that boundary there. So if we move forward in time, you can see again these loads bashing in the European mainland, pushing in milder and milder Atlantic air. If we move forward in time, what do we see? Oh, we see actually that the GFS is much more eager with pushing in the warmer temperatures much more inland, as you can see here, right? Now, yes, we don't even see a lot of signals anymore for the freezing temperatures here, apart from here in the Northern Europe. But as you can see here, there's not really a lot of freezing temperatures even at night anymore. So what we can see actually is that the GFS model, the American model, is much more eager in pushing in milder and milder and milder air towards the European mainland. What we can also see here is a buildup of a ridge here, buildup of a high pressure area here, right? And this makes it so that Atlantic disturbances don't really have a lot of chance. But check this one here. This is a nice one to see. Okay, this is far. This is wish casting. If you look at it, just out of curiosity, wow, this is a quite intense wind field with the storm actually. But let's not delve too much into that one because it's too far off. Let's take a look at our precipitation type here, what we can expect. So common knowledge would dictate that if these frontal boundaries from the Atlantic would scour over the European mainland, with the freezing temperatures more being pushed towards the east, one would think that the precipitation would not fall as a frozen precipitation type anymore. So let's see if that holds true. As all these lows move towards the European mainland, you see these boundaries here, these frontal boundaries bringing in precipitation. So does this precipitation fall as snow deeper towards the northeast? Yes. But as we go forward in time, we don't see any snow signals anymore. This is completely in line with the Atlantic bringing in this milder and milder and milder air. If we go forward, we can see the exact same frontal boundary after frontal boundary, but no snow anymore, right? There's another boundary here, and there's another boundary coming, right? I'm very eager to know what's going to happen with the system because check these intense convective signals here. So let's see what the European model is saying. We go forward in time, but you can see no snow anymore. No snow over the UK, no snow over France, no snow deeper in Europe as well, only here in the Nordics and the northeast of Europe. If you go forward, boundary after boundary, but not even precipitation signals anymore. And temperature, they're really aligned more or less in the sense that there is going to be milder temperatures, but you see this massive high pressure area here. So this prevents actually a lot of precipitation from falling. So if we look at the GFS model, compared to the European model predicts a much more dry pattern apart from here in the UK here with quite an intense storm field. I wouldn't be surprised if there are some juicy wind gusts here, as you can see, right? But it's already much too far to delve into. So what we can see now is there is quite an agreement between the American model and the European model. Both they now predict these Western circulation or the Western train kicking off with low after low after low over the European mainland. Okay, both models are predicting that the colder temperatures will start to be pushed towards the east, but the GFS is the most enthusiastic about it, pushing these higher temperatures much more deeper inland, even preventing freezing temperatures at night. There's also a difference in the precipitation field because as the GFS model is predicting wave after wave after wave of frontal boundaries, the European model is predicting also a wave or two with precipitation, but there's a high pressure area building over Europe, preventing any frontal systems from reaching the European mainland, which might also explain why the temperatures at night and early morning and late evening hours are freezing temperatures actually. Why? Because high pressure area means less clouds, meaning more long wave radiation leaving the Earth's surface, leading to colder temperatures at night. There is some depiction of storm potential, but it's too far ahead to really delve into. We will see what the next couple of runs brings, and I'll see you in the next video, guys. Bye, everybody.